Firefly's AI note tracker, Victor. Who has enabled this one?
I don't know. I just said, okay. Anybody who wants to.
Somebody might have added to this.
Welcome. So
Yeah. Only thing who have added this should be able to give us the notes. Else, definitely we can extract from this video.
I actually I opted for that free version of Read AI.
Okay.
But I checked with John. I don't know how the heck it records it because I could not get any summary out of the last meeting that we recorded.
Okay. Here is one I see, read.ai meeting notes. Not sure who has
who's
enabled
starting
on.
it, or I don't know where the heck it's recording. So that's my problem. And I don't want to pay for it and get that installed and things like that. I already have too many apps in my system.
That's true.
And when you work on networks and internet, you're scared of all these apps. Bottom line.
So what I will do now, I will just put this window down. Okay. I think we can.
Yeah.
We can start in 1 more minute. We can wait just 1 minute.
Okay. Okay. No worries.
Yeah.
We have Prasanna and Chitas now.
Hi, guys. Both of you are very silent. Well, I know ladies talk a lot, but come on.
Else we will not give a chance.
Yeah. Can you guys hear me now?
Yeah,
Yes.
good
Yes,
to hear
Prasanna.
you, Prasanna. I think I forgot to respond to one of your emails. I apologize. I'll get back to you. It's been a crazy week, so
Sure,
it's
yeah.
like,
Yeah, I came from vacation yesterday, so
okay.
yeah. So I have to check my emails again.
No, I did not. You were asking about being a member.
Yeah, right.
And my apologies again, to the whole team, because writing up that technical working group application, filling it up was crazy. It's gone up to 15 pages now. And I'm hesitant to put it on a Google Drive or something because I don't want to get any feedback now. So let us see how it goes. It's almost there. I have to give it a final read and submit it. So I think I have those of you who expressed interest in industry, etc. I put you in as industry coach, liaison, and things like that. Don't worry about it. At this time, I'm just focusing on getting it approved. Okay. Okay. Shall we start?
Yes, we can get started, Nirmala. Yeah.
Okay.
Sorry, I got late.
Okay. Good afternoon, everybody. Okay. This happily went off. Okay. So growing AI demands challenges from AI models to networking infrastructure, etc. What I had in mind, I don't know how descriptive this title is, but I'm hoping the abstract was clear because with the growth of AI, if you notice, there are several domains, several areas that are impacted. As far as this special interest group is concerned, we are focusing more on the networking aspects of it. And it's just not the data centers or things like that. It's the internet. Everything is contributing or rather hampering the growth of AI because the demands of AI are something that is completely, we have not known it in the networking world earlier. This type of demands that you get because you're supporting AI is very, very different from the communications demands we were placing on both the internet and the data center. So primarily what I'm trying to do in this talk is what are the different domains and technologies that are being impacted by the AI growth? How many of them are coping pretty well, right? And I'll give you some statistics also. and what is the role played by each of these technologies, like servers, models, algorithms, etc., and which of these technologies is really being a bottleneck for the AI growth. Okay, so there are so many technologies, and I may not have covered all the technologies here. There are so many technologies out there that are impacted by the AI growth, that have to make accommodations to support the AI growth. How well are those technologies doing? And is there a bottleneck in these technologies? What happens when you scale? Because when you talk about distributed AI, and AI is not just all the operations in one GPU, TPU, etc. It is clusters of them which are spread across servers, which are spread across data centers. So networking invariably comes into play into all this. So when you start scaling AI, okay, how much capacity can you put into one processing unit? Only a certain amount. And I have some statistics on that also. So you do have to cluster them up. And when you cluster them up, they may be, you could have 10, 20 GPUs in one server, but then you have to communicate across servers. So as you're scaling the AI needs, scaling to the AI needs, this distributed AI infrastructure has to be supported. And what is supporting the distributed AI infrastructure? It is our networks, okay? So what is the problem then? Is there a problem with our IP-based networks? It's been surviving for 30, 40 years. So what is the problem there, okay? And then I'll try to sort of boil it down to the importance of AI native networking, because the type of traffic that the internet and every other network has been seeing till now is very, very different from the AI kind of traffic. So that's why you say AI native networking. AI application requirements are so very different from the applications that we have been running on the internet and our data centers and things like that till now. So I'll sort of summarize it on the importance of AI native networking. And where do we go from here as a team? Where are we heading to? So if you are looking at the growing AI demands, what are some of the challenges? Obviously, the computing needs are just enormous, okay? There is the communications bottleneck, because just like I explained a few minutes ago, you're not going to do all the computing in just one processing unit. They have to be across multiple processing units. Even if you say clusters, there is a communication there. You have to exchange enormous volumes of data, okay? Energy consumption. I don't know how many of you check the news, but that's the first thing that I do when I get up in the morning, turn on the news, and anywhere they try to install a data center, there's this big hue and cry from the town or city people saying, hey, we don't want it because it's going to suck up the energy, okay? Obviously, so much of energy, so much of heating up, you need all this cooling requirements. Memory. You might be surprised with the growth in memory. Is there a memory limitation at all? So we look at the relative scaling. What is the computing? At what rate is the computing needs for AI growing? And what is the problem with the memory growth? Okay. Storage throughput. You have to move the data, store it, pull it back again, and again, there also communication comes in. So wherever you see a red, I'm trying to highlight that some kind of communications, network protocols are coming into play. They're all there under the hood. We just don't see them. We just say, oh, it's not working fast enough. Oh, my GPU is just idling away. Why is that happening? It's happening because there is a lot of other technologies that are taking a part here, okay? Fault tolerance. When you have these large clusters, given how reliable our technologies are today, it is surprising that failures do crop in, and they are pretty frequent. They're not negligible. So they are quite frequent. So how quickly are we able to recover from these failures? Just 1 second of downtime. You can imagine at the rate at which we are processing data and moving data across, terabytes, terabits, whatever it is you want to call it, fault tolerance is important. I should cut down on the failures and I should recover quickly. Scheduling complexity. I don't know how many of you understand this part of it. If some of you do, my apologies. I'm trying to be a teacher here and explaining everything in detail. So you have these multiple servers with, that's forming this GPU cluster. Okay, those servers are sharing a job. So one job is sent to multiple servers in a data center, and those servers have multiple GPUs that are doing the processing. So the data has to move or shuttle between the servers as quickly as possible so that you complete the job and deliver the results to whoever the job originator is. So what sort of scheduling do we have? That scheduling is highly complex. Okay, it has to have a network picture. It has to have this. Where are the servers located? What are the job requirements? Is there a congestion there? And numerous things. Okay. Last but not the least, security, privacy. You're handling very sensitive data. Security and privacy is very important. And all of us are probably well aware how bad IP is in terms of security and privacy. We have 101 patches, but still we never get there. Okay, so growth of AI and its impact. So I'm sorry, I just did all this in a bit of a hurry. So that is our AI, this nice, very comfortable thing. I use it a lot, by the way. Okay. When you want to pull statistics fast, nothing like using ChatGPT or so on. So I have this artificial intelligence, nice technology, but underlying this artificial intelligence that are models and algorithms, I put it in red because that's not my expertise. If anybody has expertise in those areas, that would be a great talk to give here. Okay, but obviously the efficiency of your artificial intelligence operations highly depends on the models and algorithms that you use. And basically, I noticed one thing, I've been in this field for 30, 40 plus years. We are all very comfortable in using well-proven technologies and, reuse it, retrofit it, and keep adapting it. That happens with networks a lot. We don't want to think out of the box and come up with new solutions. I don't know if that happens with models and algorithms because they are literally the operating system of your AI. Okay, and if they are not efficient, your AI is happily going to be churning, doing a lot of computations, wasted computations, like what we have in networks today. And networking is my research area, and I know how much of unwanted operations we are doing in all our network devices. So that is about models, algorithms. I'm not going to talk about it anymore. Okay. GPUs, TPUs, accelerators. You may just want to look up because, they have high processing capacity. One is supported by NVIDIA, the other is supported by Google and things like that. They are all processing chips and they use multi-dimensional arrays to do their computations. Okay. And their growth has been phenomenal. And for all these processing to happen, you always need memory. You temporarily store, pull it back, and so on. And they have to be very fast memory. There is a new technology, remote direct memory access. Then that should tell you if somebody has come up with a technology, how important is fast memory access for AI. Okay. Servers. Now, all the processing and all your GPUs, TPUs, etc., memory, etc., they're all sitting in servers. And then you're connecting hundreds and thousands of servers in a data center, and they are doing the jobs in a distributed manner. So servers manage the processing, and then you have AI, it's of no use without data. Okay, it needs all the data. You need the data to train, you need the data to process. So you have to pull all this data from different sources, and you do all your processing in your GPUs and TPUs, memory, which are all sitting in your server. I'm trying to draw a big picture here. Okay, and then after you have done processing the data and whatever results you get, you have to send it out to whoever needs it. Okay. And then comes the links, very, very important. There was a time, again, I did my PhD long time ago. We didn't have fiber at that time. We had, I don't know if you guys ever heard of coaxial cables and twisted pairs. Anybody? Does that sound familiar? I thought those would be outdated technologies. So with fiber links, you're moving the data, right? You're processing them very fast with the GPUs, TPUs, etc. But then you have to move them equally fast, and our fiber links are able to do that. But at every point, there is a little bottleneck. So what is that bottleneck? We'll see later. Last but not the least, the network devices which are going to route the data to the server, route the data out of the server, across the internet, across the globe, across multiple data centers, between servers in a data center, it's all networks. Okay, it might look like simple, it's sitting at the back, it's doing its job. How well is it doing its job? Okay, so related technologies. Let us look at some processing technologies, like your GPUs. I did not put up TPUs here, GPU is from NVIDIA. And if you see the growth here from 2014, that is supposed to be close. What the heck is supposed to 10 to the 12 floating point operations per second. That is your T flops. Okay. So it has been growing for the last decade or so. And currently we are hitting that many T flops, and there is a P flops. They really stump me, these terminologies. Is it impressive? It is impressive. By the way, this is something I tell my class every time. My master's project, when I was studying in India, I did it in a company, was to program an erasable, programmable, read-only memory. Have you ever heard of it, EPROMs? And the EPROM that I had to program those days, it was a 2 kilobyte, 1 kilobyte memory, okay? And it was this fat, that big, 2 fingers put together. And to program it, I was using a microprocessor kit, and I had to give it plus 65 to minus 65 volts, okay? And if the duration of those pulses exceeded by some fraction, the idiotic chip will blow on my face. And those days, those chips costed 2,000, 3,000 rupees. And, it was a scary project for me. This is 30, 40-year-old technology. Compared to that, we throw away chips nowadays, right? Every card that you use when you enter a hotel room, you throw it away. And there's a little chip sitting inside, which has got much more capacity than that EPROM that I programmed 30, 40 years ago, okay? Impressive. I think it is impressive. I have an electronic engineering background, so I do know that this is impressive. So no problems in this technology, okay? How about the memory? Compared to the compute growth, the memory growth is not that much. It's the memory bandwidth, the rate at which you can send and receive data from the memory is it's doubling every 3 to 3.5 years. whereas compute throughput doubles every 1.5 to 1.7 years. Quite a bit of difference there. So memory, is it a bottleneck? I'm not an expert in that yet. Links, okay, fiber links. Oh, we think we are just pushing data on the fiber link, but there is one little devil sitting there, and that is a physical layer protocol. That is the one, the moment you talk about protocols, you're in trouble, okay? There is a physical layer protocol that handles encoding, decoding, receiving, sending, et cetera, et cetera. There's a lot goes in at the physical layer. But if you look at the transmission data rates alone, that is the growth. 1970s, it was probably kilobits per second. We never even had a terminology called megabits per second, maybe, And today at the AI cluster edge, we are looking at 40 petabits per second. That is 40 into 10 to the 15. So the fiber link itself, very impressive growth, okay? The data rates, that raw data rates that you can get on fiber links is really impressive, but you have this little devil sitting in when you're doing the communication, and that's your physical layer protocol. How about the servers? Okay, remember all the GPUs are not just sitting there doing the processing. They are all housed in a server like your computer. It's got a CPU inside. Similarly, you have the servers. They have the GPUs, memory, etc., etc. But the servers and the GPUs, memory, etc., they have to move a lot of data. And to send and receive data, they are using protocols. And believe it or not, it is a whole complex underlay, overlay, whole bundle of protocols sitting in the servers. And that is the one that is going to impact what you get out of your GPUs. Your GPUs might process them very fast, but what is the server doing? Okay, it has got its own limitations. So anytime you see a red highlight there, that means you're facing a challenge here. And like I said, most of them are predominantly IP-based. There's a new technology called InfiniBand that's completely doing away with IP, okay? Because IP was not designed for this sort of a technology at all. This type of a high-speed processing, no, it was not designed for that. How about networks? Okay, you have the servers, and they are all connected. They are put in a data center. You will have thousands of servers. But how are the servers going to communicate with one another? You have a data center network. You have network devices, routers, switches, etc. Typically, I would call them routers. Some of them prefer to call them as switches. Is that it? No. I have to pull data from every corner of the world to process my information. Okay, that is network. That is the internet, ISP networks, enterprise networks. You pull data from all of them. So again, the speed that you get with your GPUs, your physical layer, memory is also probably relatively good. This is our bottleneck. Okay, if they do not give you timely data, reliable data, how fast are you going to process? What is the point of fast processing? Okay. Last but not the least, security and privacy, because your data, unprocessed or processed data, is traveling all over the internet using IP. How secure are they? Okay. So this is a nice chart that I got out of ChatGPT, and this is the different components that we just talked about, and that is the growth since 2010. I'm going to share the slides with you, so I'm not just going to read from the slides here, but just have a look at the growth of the model sizes and the training clusters. And when you say clusters, you're talking about GPUs across multiple servers. With that growth, already they're having problems with the memory. The compute capability, probably it's adequate enough. The link capacity is also great, but our servers and networks have a serious problem. They impose a limitation on, and that's why, recently you see all these fancy words, AI native networking. Okay. So communication becomes the bottleneck. This is the type of traffic that they characterize for AI. It is not your typical IP traffic that we had before the advent of AI. Okay. So what this is, again, I'll let you guys figure it out. So communication can consume, the data can consume 30 to 60% of iteration time. And your GPUs can be sitting idling there. If you don't schedule them properly, scheduler is very important. The movement of data is very important. All these contribute to the efficiency of AI operations. Okay, so if you look at it, GPUs, if you don't give them timely data, they're going to be idling. However high their capacity is, they can't do much. So the focus of all these, latest technologies, Rocky still uses IP, InfiniBand completely does not use IP. I'm struggling for words here, sorry. So, but one more fundamental problem is the energy consumption and the cooling requirements. We are unnecessarily overloading our servers and networks with the huge amount of processing. I think I said I'll share my OCP talk with you because it has got all the technical details. Why is the current networking so process intensive? Why is it so memory intensive? What is the problem with IP? What is the problem with TP? It gets very technical. So it is there in my other set of slides. I'll try to put it out somewhere. No, I think it's in my LinkedIn page. Sorry, I put it up there. Okay, so anybody wants, you can go there and check it out. Detailed operations, what is happening with IP and its protocols. So like I said, whether you look at InfiniBand or Rocky, they are not cutting down on the complexity of operations. That is, thinking out of the box is very important for us. Most of us don't like to do it because people out there will not accept you like I'm struggling for acceptance. How can you simplify that and you can cut down all these complex operations and get numerous benefits out of it? That is my research, by the way. You want to know a little bit more about my research, just get into my research page. It's there in my RIT web page. Okay. So important takeaway, networking has become a first-class bottleneck alongside compute, memory, and power and next. So it is struggling in terms of the computational needs, memory needs. It is hogging all of that. Okay. So while your servers that are having all these GPUs, etc., are getting heated up because they are also running so many protocol layers, your network devices, and one data center has got thousands of these network devices. So such heavy computation in each network device, they're going to consume so much power. They're going to get heated up, okay? So the compute is not only a problem with your server and GPUs, it is a problem with the network devices. Memory hogging, it's not a problem only with your servers that have the GPUs and need memory to store. It's also a problem with the network devices. I'm hogging memory just when I don't even need it. So the power requirements accordingly, servers are going to consume a lot of power, reasonable, so is our networking devices. Now, which one is really hogging in a data center? That is some research I have to still work on. So AI clusters, those are some numbers I pulled out, and believe it or not, it's a fact. Okay. So what are the challenges when you have to move data across hundreds of thousands of GPUs and accelerators like that. You cannot tolerate latency. You cannot accept congestion in the network, and your networks are heavily connected. Check up a folded clause topology. It's a heavily connected network so that you have redundancy in path and you have this multi-path routing. One path fails, other paths are available. Quick recovery from failures. I thought with the rugged equipment that you have nowadays, failures will be pretty low, but it's not so. Why are there failures? Because every network device requires a huge amount of configuration. And the first reason for any failure is human configuration errors. Okay, so fast failure recovery, load balancing. Okay, you have multiple paths, balance the load across the servers, minimize any packet loss. A little bit of packet loss and you probably have to resend all the data. Okay, that's not acceptable. Okay, so there is a heavy dependence on networks, network performance, network technologies, and who is the culprit here? Not the network devices. Hardware and software have become so reliable and dependable nowadays. It is the protocols that are running in those devices that are the culprit. Okay. When you look at distributed and large-scale AI infrastructure, a lot of networking comes into picture here. So what is the problem? Okay, why am I repeatedly saying that networks are a problem? They have to do that. They have to have low latency and so on. But there's still a problem. There is congestion. They're not load balancing properly. They're not scheduling properly. What is the problem? The problem is the network protocols that we are using. Everything else has advanced significantly, leaps and bounds advance. Okay. But if you look at the network protocols, believe it or not, guys, all of you are just using those 30, 40-year-old protocols. Okay. While every other related technology has seen significant growth, isn't it surprising that you're still using 30, 40-year-old protocols, internet protocol, routing protocols, ECMP, everything is that old. And they were all designed for technologies that existed, technologies, communication requirements that existed 30, 40 years ago. Consequence, heavy, clunky operations. You should look at some of the my PhD was in computer science and network. Okay, in networks we use tree algorithms because we can't have packets looping. All our networks are heavily connected, so there is a high probability that your packets will loop. So all the paths that you are defining have to be loop free. And guess what we use? We use computer science spanning tree and Dijkstra tree algorithms, which were designed for a totally different problem. Okay, we try to retrofit it into our networks and we make our protocols that complex to build a spanning tree, to build a Dijkstra tree, and that's a fact, guys. Okay, heavy, clunky operations, heavy complexity. And when all these get complex, your maintenance is going to be heavy, your management is going to be heavy, your troubleshooting is going to be heavy, downtime can increase. And when you scale your networks with all these complex operations, when you multiply it by thousands and 10,000 devices, what's going to happen to your data center? Increased hardware and software needs. So to get all those protocols to operate, you're going to be using so much of CPU, you're going to be using so much of memory. So it's not only for AI, even for networking operations, we need that. And that is one of the reasons for your energy consumption, the hike in your energy consumption. Costs, obviously. Okay. So an IP and security, I don't even have to talk about it. We all know that very well. Okay. Now, are these facts? They are facts, and that's where it might be good if you check out my presentation that I made for OCP. If I'm running out of time, just tell me, Vidya. I just get carried away. Okay, so why do I keep complaining about IP-based protocols and network performance? So let us answer a few questions here to understand what is the problem with these IP-based protocols. What were the goals when IP was designed 30, 40 years ago? Just go back in time and try to figure it out. You can pull it out even in Wikipedia. What were the communication technologies at that time? What were the network architectures of that time? What were the computing limitations of that time? What was the transmission technologies? 1 kilobits per second, 10 kilobits per second? We designed these protocols for those technologies, a totally different era, right? So why are we still using it? I don't have a good answer to it. But whenever I talk to the industry, Cisco and everybody else, I give this talk everywhere. Anytime I get an opportunity, I go crazy, okay? The justification is IP is ubiquitous, it's widely deployed, and it's been working. It's working, so why do I have to change it? What a reason, right? And it is supporting all the communications all over the world. Just a simple question. How do you justify using a 30, 40-year-old protocol to move data in today's advanced networks? 30, 40 years ago, I used to travel in trains that were pulled by steam engines. Would I use steam engines to pull bullet trains today? Doesn't make sense, right? But believe it or not, that is the story of networks and network protocols today, okay? So again, this is just a listing of all the complexity just because of the different network operations. I'll skip that. Scalability of distributed AI. You're talking about that many GPUs and so on, and which are operating at teraflops or whatever it is, whatever pflops, teraflops, whatever it is. And to move data between these advanced technologies, we are using 30, 40-year-old protocols, okay? So emerging network challenges. What do we have to do for AI? We need ultra low latency, high bandwidth, not the raw data rate, but what your protocols can move. If you try to look at the difference between the two, there is a vast difference. The raw data rate that you can get on fiber is pretty high. But by the time you stick in all these protocols, the effective throughput that you get is much, much reduced. Predictable performance. Can we even say that we can get predictable performance from our networks? Fast convergence. I'll skip the topology aware reduce. Okay, I'll skip all the others now for the timing. Okay. Meanwhile, having a look at what is happening in the AI world, the model size is exploding. That is some statistics again, thanks to ChatGPT. And for distributed training, I need all this. Many of these training challenges are tightly coupled to networking. On one side, the model is exploding, the processing capacity is high, and here you have our networks which are struggling to move the data across because I'm using these 30, 40-year-old clunky protocols to move the data. So I'll stop it here. Where to from here? We need to embrace, everything around us is changing. And to be frank, whenever I try to talk about IP agnostic solutions, that's been my research for the last 10 years or so, I get shot down every time because, IP is the king, you can't replace him or anything. But with the advent of AI, the last few years when AI is sort of literally exploding, you see all these initiatives like InfiniBand and so on, and I'm happy about it because one of the things that InfiniBand is emphasizing is you cannot use TCP IP stack anymore, guys. So they have come up with their own fabric, okay, their own dedicated fabric which covers servers. But the only problem with that solution is it is not backward compatible with IP. It cannot communicate with IP servers. But when you propose IP agnostic solutions, they will. And that is my research. And like I said, if you want to know more about it, check out the presentation that I gave in Open Compute Project. I'll stop. Open to questions.
Yeah,
Go ahead.
I have one question. I understand that there is a gap, and I understand people are giving explanations saying that, it works and all of that. But why is there not an emphasis on, researching, and is there a high cost involved, or I mean, why would people not look into this and
It is a
work on this?
disruptive technology. Okay. IP is deployed all over the world. 10 plus years ago, that's where I got fascinated with this research. 10, 12 years ago, National Science Foundation started an initiative called Future Internet Architecture. Okay. They funded some big universities. We were shortlisted, but we did not make it to the finalist list. Okay. So the finalist list were three of the elite universities. They were all given $8 million or something to come up with a solution. They were teamed up with industry, but eventually the solution, that's where I keep emphasizing, simplify it, think out of the box. And that requires a totally different perspective of looking at your problem, okay? So unfortunately, those three big universities, the solutions that they came up with were much more complex, or maybe the industry that they were, some of them were teamed up with Cisco, nothing against Cisco and so on. But the problem is just this, okay? They teamed us up with industry so that industry will have a say into our protocol design. We also had level 3 and one more, shoot, I'm forgetting the other industry. So like I said, we got shortlisted, but we didn't make it to the finalist list. So that was the effort taken by them. But there's something called politics, guys. Whenever I present this work or my publication, I get comments like, I'm running it in real test beds. I have coded the protocol. I have real results comparing it with, the current routing protocols, IP, identical topologies. And the comment I get for, easy rejection. It will not work with IPv4 or IPv6. Okay. So,
is there a deployment challenge, Nirmala? Then is there a deployment challenge than getting the new technology?
Like I said, it's a disruptive technology, Vidya. So, but we have to start somewhere. So the nice thing about the solutions that I'm working with is they can work in parallel with IP technologies. Unlike InfiniBand, which is not backward compatible, you can have it in a parallel stack. Okay, so I have a router. You run the current protocol stack, you run this protocol stack, which is just one protocol replacing 6, 7 protocols, okay? You turn on my protocol, it'll take over the forwarding. You turn it off, it'll push it back. Now that is the best solution that I can think of to entice the industry. But somebody has to take the risk. So that's the challenge.
Yeah, yeah.
But
That,
meanwhile,
yeah,
I have fun with my, I come up. Look, the protocol was completely designed by me. So anytime a new challenge comes up, I stick in my own solution for it. It's like, how do I say? I'm tinkering with the protocol and having fun with it, whether people accept it or not. But believe it or not, the main idea that I want all of us to understand is high time we did something about it. The limitations of internet protocol, every few months you hear about this major breakdown, and Microsoft went down, that network went down, this network was hacked, BGP was hacked. BGP is the most ridiculous routing protocol you would ever come across. And that is the one that is the routing engine for our internet. Do you know the number of entries in BGP's routing tables? Millions. How much of memory is it going to consume, guys? And how much of computing capacity to calculate all those routes and keep updating them regularly? That's what is happening in our routers today.
So, sorry, I have a question, right? So, and again, I'm speaking from my experience where, when I was a solution architect a couple of years back, I kind of implemented a lot of active workload sharing and active passive kind of a systems, right? And the systems I designed, again, they were not like, I would say very heavily loaded, but again, we were talking about the traffic between the range of around on an average around 10 to 12,000 TPS, and max is 20,000 TPS, which we hit. Right. I was basically designed the traffic for the CVS. I used to work in CVS, so I kind of designed the system for that. Right. But again, in our conversation, right, I'll be honest, right, in our conversation, whenever we are doing the POCs, whenever
you?
POCs, proof of concepts and everything. Whenever we're whenever we're doing everything, right? Again, I set up a dedicated network to GBPS for me, the network pipeline again. But I was a solution architect. I was not really at the, I would say, I'm not really deep into the network. It's more kind of like I have to talk to the network engineer or the people who are deep into the network to give them the guidance. Okay, this is what I need, right? And then they go back and set it up, right? But again, network was never ever one of my concerns. When I say concerns, right, in the sense like whenever I'm trying to calculate my, I would say the performance and everything of the traffic, right? Yeah, CPU was there, storage, or how quickly basically you can read the data, right? That was majorly the concern. So network never comes as a concern, right? We were hitting even at some of the places where we even hit even 12 milliseconds, 13 milliseconds, right? Like that kind of a workload, that kind of a performance. But so that's what I'm saying, right? So in the way industry works, right? Probably the question which I'm trying to ask, right? The way the industry work, it works on the problem statement, right? CPU, earlier the storage becomes very high. So obviously we have multiple solutions like S3 and all, which brings the storage cost very down. Compute become high, compute become bottleneck. We have GPU, TPUs, and the compute costs also they're trying to work to make it down, right? But network, for some reason, right, at least in my so many years of experience, I've never heard it as a bottleneck. I've never seen it, although we have gone from kbps traffic to tbps traffic right now, right? Or even to petabytes now we're trying, but same network is able to handle it. So my question here is like, why? I understand the emotions, I understand the need to innovate, okay? Right? But I don't see the real industry challenge, right?
No, the problem is, like you just now said, it works.
It works.
So as a researcher, you look under the hood. And then you see this mess of operations and you say, oh my God, do I really need it? Not with the current day technology. Okay. And if you get nice data rates with our networks, because that's what we are all looking for. Am I getting these speeds? Yes, I'm getting it. So what is giving you those speeds? It's those great transmission, all your fiber links, the high processing capacity and everything. That is sort of covering up for the, how do I say? Sorry to say this word. I don't mean to hurt anybody's feeling. The mess that is getting created by the protocols. If you really track the traffic, shall I give you a simple example without getting overly technical?
Yeah, no, you can get as technical as well, right? Please,
The thing is, because I literally trace all the packets that are going in the network. So
Correct.
we were besides the data center network project, we also are working for a solution to remove IP and OSPF that runs in enterprise networks. Most enterprise networks, ISP networks, run OSPF. OSPF again was designed 30 plus years ago. It uses the Dijkstra tree algorithm.
Hmm.
It constructs a Dijkstra tree from every router to every other router and then populates its routing table. And when two routers on either side of a link, they get the link state information. And that link state information they disseminate to the whole network.
Right.
And as per the Dijkstra tree algorithm, it assumes the network is a directed graph. So when one link fails, node A on one side of the link tells the whole network, hey, this link is down. The other node,
Right.
he sees the same link state change and he also advertises to the whole network or area. Do you really need it in today's world? How about designated routers, backup designated routers?
What we have that, right? So what you're talking about is like whenever like around the switches and all when we build the routing table, right? So we, in fact, when I did set up my GTMs and LTM, right? There was a backups and backups of backups, right? So there's a high availability and there is a high availability, disaster recovery and high availability, right? So we always work on those concepts. So we do set it up. Yeah, if we are, God forbid, we are in the bad day, even the high availability phase, then it is gone, I get it. But we do have the backups and backups of backups and the way at least the systems, whatever I have designed, right? We do have all this scale up and scale, all those kind of horizontal scaling, vertical scalings, everything get designed so that even if there's an unexpected traffic, right, we're able to handle it out. So in short, right, and this is all with the cloud coming into the picture, right? This is actually really help us set up this kind of a traffic, right? Where I think I'm struggling is like, I understand there could be some unnecessary routing table updates. Let's say one of the node, for whatever reason, one of the domain picks up that one of the node is down. For whatever reason, health checks are failing again and again, because health checks also there are rules, right? If it fails thrice, you check after wait for some time and then you check and then you make those node as a dead, right? So that part I get it, right? But again, I still, I mean, even after that, all those unnecessary thing, right? It's still working.
And yeah, that is the comment I get. It works, but
I think the problem,
how do you get so many failures?
right?
Why is your maintenance so high? Why is your troubleshooting effort so complex? Why do you get configuration problems?
But the problem with that is, the solution which you're proposing, right? Uh, uh, See, you are justifying the cost as a driver, but the solution
Not cost, complexity, performance,
Correct.
management, troubleshooting.
Right. Everything in the industry term, if we talk about it, everything at the end got attributed to time and money. Okay. At the industry, I don't understand any third topic. Believe me, at least I don't understand. Okay. You can bring me any complex problem and there will be only two questions. How much time, how much money? Okay. That's what
Time and money.
correct. Right. I get only asked these two questions. Right. So coming to that, right, in order to answer that question, I understand that you have a solution, right? which you are trying to put across, and I trust you 100% that it is definitely one of the better solution also, right? But again, I think there is one problem, which is basically the backward compatibility, right? That is
taken care of.
oh, you have taken care of that?
Yeah. When
Okay.
you get time, or whenever you guys are ready for a heavy dose of network stuff, I will give you the details. I don't need a routing protocol, guys. The networks are so beautifully structured nowadays. You know what? Okay, 30 plus years ago, I did my PhD in networking.
Mhm.
You know, we use stars and hubs and rings and things like that. Nowadays, you know, I don't deny that those sort of topologies are there, but you have beautifully structured networks. And that structural information has got a wealth of information that I can use for routing. My network solution requires almost zero configuration. Do you know how much configuration goes into an OSPF router?
Yeah. So, but
Do you
again,
know how much configuration I use?
but how, because normally in today's world, it works the way the internet works, or the way it is working is works in the domain, right?
Yeah.
You have a IP attached to a domain, right? And then internally you do whatever you have to do, right?
Come again, Chitis. I missed you.
You have an IPv4 attached to a domain, right? Or IPv6 in terms of, if you're talking in terms of the devices, right? So, right, and that's how we kind of identify our traffic, or that's how we kind of map the route, right? And that goes to the different domain sites, which is like one of the 5 or 6, whatever we have, right? GoDaddy, and there are a couple of others, right? So that's where it get routed, or that's where it get mapped, right? But how will I mean, at the end, domain needs an address. So how will you provide the address if not
Okay.
routing?
Why don't we arrange this presentation sometime? The others don't want it. It'll be between you and me.
No,
Chitis.
No, I think
what-
I took a lot of time. I'm
Yeah.
sorry.
So what a suggestion I have, right? Nirmala, actually most of us like working at the most of software end, where for us it is more of like the network is like totally, we don't look at much at the, as it is as suggesting, right? Whatever is available, we will do the configuration, we will do the backup, or we will do the recovery systems, right? For that, but we don't go beyond that. So if you could, I think two things. I think from my side, I feel like what challenges you have, if you can share some documentation, and we can set up one more session, deep dive, like on your research also. So we will understand what is going today in the industry, right? What is working today? What challenges we have, and the new research areas. What are the directions and how they're going to help? So that way, our whole group will actually understand, rather than just not looking from the software point of view, but from the networking point of view. When I am saying AI, how underneath it is working, I think that is a getting a full picture of it will help us, help every one of us.
I'm happy to talk. I love talking.
But I
I'm
want
a
like
professor, guys. I
yeah,
love talking.
but I would like to do some homework before coming to your next session, so that I understand each and every concept, and also I understand like why we need a research, first thing, second thing, and how this new research is going to help to improve what challenges we are facing. Because when the challenges we are facing, there are more on the business side, but underneath there is a networking challenges. So we can correlate between the two.
So, like I said, if you get a moment, I posted when I presented the talk in OCP, they sort of recorded just my face, not the slides.
Oh,
And,
okay.
I have this habit of, typically our Indian faces, we just emote like anything. And so I sat down and re-recorded all the slide explanation and posted it on my LinkedIn site. So people have a knowledge of what is this technical stuff that is happening here. Okay. So
Okay.
if you get a moment, check it out. Okay.
Sure.
Or I
Sure.
can post the YouTube link on our email list.
Sure. Yeah.
Either way.
We can actually, in our channel also, we can post it that Nirmala and the whole group can, get benefited out of it. And I would like to have one more session with you, uh, with the research direction which we have. I'm interested definitely to hear from that. As Shri
Like
is
I
saying, okay,
said,
everything is
guys,
working, but what we need and why we need a research, that understanding would help us.
the other thing is, you know, uh, I am sort of soaked up in networking research, and I've been like doing networking all my life. I literally, even in my lectures and classes, I trace the packets that are flowing through, and I try to understand how the network operates. But if you look at it, there are so many other technologies that was the whole idea of this talk. That's where I did not give much details about the networking.
Yeah.
There is the AI models, there is the AI algorithms, and that's where I gave you an example of an algorithm too. We are all very comfortable to take a working solution, retrofit it, and adapt it and apply it because, quick solution. Okay, the advantage that I have as a professor is I have all the time in the world to sit back and enjoy whatever I'm doing, think it out patiently. If it comes out good, if it does not come out, okay, no worries. Okay. So when
Yeah.
like Chittis and the industry like you guys, you're time constrained. Okay. You have to come up with a solution within a given time. So you take whatever is there, and that could be happening in the other areas also. Like, for example, hardware design, I'm totally lost. I am an electronics engineer. I learned about microprocessors and things and all that, how the internals work, but I'm sure I'm going to be totally lost with the GPU. So we leave it to the experts like NVIDIA and Google and let them think it over. Okay. So all that I'm trying to highlight here is AI is not going away. Okay. So it is there to stay, you see all these fanciful advertisements about, hey, what is the AI buddy for Google? I don't know. Why is my plant going away from me? We use it literally for everything nowadays. Okay. So it is there to stay. But the challenges, and you are folks from different areas. So are you seeing something that could be made more efficient if you just could think out of a box? If you have ideas, like I said, if you want resources from the university, if you want to hire students to test out your ideas, you are more than welcome. I can surely help you out there. So what I said is from my experience, and I'm sure under the hood for each of those technologies, there are some problems, and some of you folks are, you're working in algorithms, and I'm sure there are 101 AI algorithms out there. And you see a problem and you say, hey, I think I can do it in a different way. Okay, you will not have the time to do it. So as a university professor, I can give you the resources. Okay, so let us make the best use of this synergy, right? Okay, we can relax and do our research, do your research for you and everything. But if you find a problem, now this would be a good venue to say, hey, this could have been done in a much better way, different way. Why is the model exploding like this? Is there a better way to do it? Right? I'm just throwing some questions around. So that's the reason I spent quite some time and, picked up all these different technologies, and I said, okay, what all is impacting AI? What are the different domains that are impacted by AI? And I'm sure I have only covered half of it. There are much more there. Okay.
Sure.
Sorry. I have a dirty habit of I keep talking. I
No
start
problem.
talking,
No,
I
I
won't
know
stop.
we are 12 minutes over the time, but I think this was a really good insight, Dr. Nirmala. And then we will definitely set up one more session with going through your previous presentation, right? We will go through
Okay.
that and we will understand the research area which we are talking about, and that one more session we can have in detail. Yeah.
Happy to.
Yeah, and this was definitely insightful to me because I think this is not a topic where I mean, generally when you're working to your point, right, you may not deep dive into this aspect. So makes us think. Yeah.
There was a time when I was in India, I used to work in I don't know if you have the CSIR labs anymore. They had a Central Electronics Engineering Research Institute in Chennai. And I used to be a research scientist there. So, that's not really industry, but, I still had time commitments. I could not do this free thinking that I do as a professor nowadays. So I understand the pain that you guys face. Okay. I have worked in those environments long time ago. And 3 years I worked in Singapore also. It was like couldn't do much research there. So
Sure.
One thing,
Yeah.
Nirmal, I have some questions regarding the packet transmission laws. Can I ask those questions in the next meeting?
you can also arrange one-to-one meeting with me, guys.
Yeah, sure.
When I say, hey, you know what, I have a great solution that can replace IP, etc., etc., I'm sure several of you think this lady is crazy. I'm not. Okay.
Yeah, we have some. Yeah, we have some servers. We are facing, the packet transmission loss issue from a couple of months. So we have a monitoring tools. Those monitoring tools are, keep on saying that there is a packet transmission loss. So I'm talking to my networking team, but we are not. They're just
I'm
reducing
happy
the
to.
packet transmission type. I don't know what is type, or I don't know. They're just increasing and decreasing the packet transmission, but still we are having that issue.
I'm
So
happy to look into it.
sure,
That is the type of work I love.
yeah. So yeah, I'll contact you.
Okay.
Sure.
Okay, guys.
Yeah. Thank you. Thanks, everyone.
Thank you.
Thank you, everybody.
Thank you.
This is really a nice session, Nirmala. Thank you.
Bye.
Thank you.
Thanks.
Okay, where is my